As built for AutoCAD. Feature Data Tutorial. Facade Damage Mapping. Part 2 of 2. Customize a structure definition. After this tutorial, you will be able to change the name of the structure definition, customize and add new attributes, sort attributes, add new visualization types, and reuse your structure definition. Notice, for demonstration purposes, we will speed the video up in certain areas. If significant changes are made, we will review them and resume the video speed. Please watch As Built for AutoCAD Tutorial Facade Damage Mapping Part 1 before viewing this video. For a detailed description of every command, please refer to the user manual. To be able to work on this tutorial, you will need a fully installed version of AutoCAD into which As Built for AutoCAD has been embedded. Within the As Built Feature Data tab, in the Help area, select Tutorials Mapping Tutorial 2. The drawing tutorial2.wg is opened. This facade plan was derived from a rectified image. You will change the structure definition when working on this tutorial. Therefore, we are working in the lower part definition of the structure view. The definition contains all the information of the data structure. It defines which data have to be captured and how they are linked. Double-click Definition. You find Classes and Links. Extend both. Since we will customize the structure definition, let's rename it. Right-click Definition and select Rename Structure Definition. Change the name to Mapping 2. When working with German As Built, you can change the language from English to German. Keep it English for this tutorial. You can also add a version number and a description. Now the Structure View heading displays Mapping 2. Now let's customize an attribute definition. Extend the definition in Classes. Extend Mapping Area without graphic based on area by double-clicking or click on the plus. Then extend Attributes and have a look at the Material attribute. The red mark at the icon indicates that a visualization is defined for this attribute. The attribute type is shown in brackets after the attribute name. For Material, an extendable selective list was defined. Right-click the Material attribute and click Change Attribution Definition. Rename the attribute to Type of Stone. The description will be shown as a tooltip in the attribute dialog during data collection. Change it to Type of Stone, Select or Add Material. The attribute type will stay an extendable selective list. This way, the user is not limited to the stone types we define. We can add further stone types during data capture. In the extendable selective list, replace the current values with these: Not Defined, Sandstone, and Limestone. Pick Show Selection Sorted. In the Fill-in Help area, pick Offer Last Value and click OK. Let's test our structure definition changes. Zoom the top left corner of the building and map the stone underneath the cornice. To do so, right-click Mapping Area and select Add Mapping Area Inner Point. Click inside the stone's boundary. The area gets highlighted. Press Enter to confirm. Click in the drawing to place the label. Select the following attributes: Sandstone, Little, and Repair. Click OK. In the Structure View, you find the newly created Mapping Area 1 with the new Type of Stone attribute and the other attribute values we just entered. Now, let's display the damages at the stones more differentiated. We do not only want to state the degree of damage, but capture the type of damage too. Our considerations result in the following types of damage to be distinguished: sanding, scaling off, crumbling, and contour scaling. These types of damage are to be used in any combination with the existing degrees of damage. We create a new attribute for this. Double-click Definition, then extend Classes and Mapping Area without graphic. Right-click Attributes and select Add Attribute. Enter Type of Damage as Attribute Name. You may add a description that makes sense and is easy to recognize. In this case, leave the description area blank since type of damage is sufficiently descriptive. For the attribute type, select Extendable Selective List. In the Extendable Selective List, replace the default entries by the following values: sanding, scaling off, crumbling, contour scaling. Indefinite, click OK. Now, the attribute name damage as a description for the degree of damage is confusing. To make it easier to distinguish the degree of damage from the type of damage, this attribute will be named intensity of damage. Right-click Damage, Extended Selective List, and select Change Attribute Definition. When the warning opens, click Yes, since we want to change the attribute name. In the attribute definition, change the attribute name to Intensity of Damage and confirm with OK. The attribute name is changed for the already collected data sets automatically. To verify the changes, create another mapping area. Right-click Mapping Area and select Add Mapping Area Inner Point. Click inside the stone's boundary. The area gets highlighted. Press Enter to confirm. Click to place the label. Now select the following values: limestone, heavily, repair, and crumbling. Click OK. See the new Mapping Area 2 in the structure? Open Mapping Area 1 by clicking its label. See that the attribute type of damage has automatically been generated for the existing stone Mapping Area 1. It was filled with the standard value, which in this case is indefinite. The yellow question mark at the attribute icon indicates that its value was not selected or verified by the user, but a default value has been assumed. Double-click the attribute and change it to scaling off. Click OK. Important: you should avoid changing a structure definition after having recorded data already. Always think the structure definition through before capturing data. The order of the query for the attributes corresponds to the order of their generation. When sorting attributes, you can control the visibility and order of the attributes. Go to Definition Classes Mapping Area, then right-click Attributes and select Sort Attributes, Show Hide. Use the arrow keys between Hide and Show to rearrange the attributes. If you select Sort Automatically, the attributes are sorted by alphabetical order. The perimeter attribute is uninteresting in this connection, and therefore we will hide it. Click OK. You may have noticed the colors change in the drawing whenever attributes are changed. This happens because we have different visualizations defined for several attributes. You can update the order of display by clicking the command in the visualization area of the As-Built Feature Data ribbon. Let's hide the visualization defined for the Measure attribute. Right-click Measure, Repair, select Visualization, and click All. All entries are moved to the Hide area. Click OK. Now we only see the intensity of damage. The new attribute type of damage does not have a visualization yet. The existing visualization of the type of stone does have to be changed as well due to the change of name and the connected change of contents. In the upper part of the structure view, you can switch the visualization on or off of the according attribute. In the viewer mode without license, only the visibility of the visualization can be controlled, but not its definition. The definition for the visualizations are created under Definition, Classes, Mapping Area, Attributes. Now right-click Type of Damage and select Define Visualization. Click Generate Automatically. Select Hatching. Since the layer Viz Damage is already used for the damage intensity, define a new layer Viz Damage type. This helps controlling the visibility via the Layer Manager. Select Vary Color. Click Next. Here you may change and customize the characteristics of the hatching in detail. For this case, leave the settings as they are. Click Finish. The colors may not meet your requirements. To change them, proceed as follows. Click the color entry to be changed. For example, Index 1. You can select a color for the pull-down menu or click Select Color and a selection box opens. Select a new color. You can follow the same steps for the other colors. After finishing the definition, click OK. See how the visualization is activated right away according to the selected damage type? Do the same steps for type of stone. Select Hatching, the Viz Material layer, and the Vary Color option. Click Next. For the style, select ANSI 31. It is equivalent to a 45-degree line hatching. Thus, it can be laid over the solid visualization of other attributes for combined display. Set the angle to 0 and factor to 0.01. Click Finish. Now we have a visualization for the value not defined. We don't want this value displayed. Select a line and click Delete. Now select the colors for sandstone and limestone. To easily distinguish limestone, click ANSI 31 and set the angle to 90 degrees and click OK. Click OK again. Now we can see damage type overlaid with the hatching for the stone type that has been generated. Let's configure the legend for type of stone. Right-click and select Define Visualization. Click Configure Legend. Here, we find the types of stone listed. The Identifiers column shows the names that are displayed within the legend. Change the identifiers of sandstone to reed sandstone and limestone to shell limestone. Calculation of totals. The cross for the totals means that the area values are added up and shown in the legend. You can control the display of the totals individually by clicking in the line and using the ellipse or via the buttons on and off. Keep the totals calculation activated. You can modify the header. You can change the text size. Values not used in the mapping may be omitted with the Hide Unused Value Range option. For now, keep it unselected. Click OK twice. For testing purposes, insert the new legend. Right-click Type of Stone Limestone and select Visualization. Click Insert Legend. See the type of stone with all the details. Note, the number of decimal places for the area values are conformed to the set grade of accuracy of AutoCAD. We can also use symbols to visualize information. Click the Insert tab and Command to see the AutoCAD blocks available in this drawing. Preserve, Repair, and New. The measures are to be visualized by these symbols. Right-click Measure, Extendable Selective List, select Define Visualization. Select Generate Automatically. Now select Block, Viz Measure, and select Color by block. Click Next. For the block, select any entry, for example, Repair. Click Finish and Yes. We don't want the no measure value displayed, so let's delete the line. In the Preservation line in the Visualization Settings column, click Repair, select a block preserve, and click OK. Do the same for the Replace line and select New. When you confirm with OK, the blocks will appear within the drawing right away. For a printout of the mapping, it is advisable to switch off the Labels layer. Now insert the legends for the type of damage in the measures. This is how the final damage plan could look. Let's change the label layout. Larger labels are desired, and the layer on which the labels are placed will get another name. Go to Layers and turn the Label Mapping Area layer back on. In the definition, right-click the Mapping Area class and select Configure. On the Label tab, find the options for configuring the labels. Layer for Label. Rename the layer to My Tutorial. Change the label size from 0.04 AutoCAD units to 0.06 units. From the three layout options, pick Label with Frame. At last, uncheck the option Label Compact, click OK. All labels of the according classes are adapted to the new display settings and moved to the new layer. When creating new objects now, the according labels will get a pointer tip. Here is the pointer tip example. We have finished the definition of the mapping structure and want to save and share it. Go to As-Built Feature Data and pick the command Save Structure Definition. Save the file in a location easy to find. In this case, we will save it in the app data in the subfolder called Templates. Now select the following folders: Feature Data, Heritage Features. Name it mapping_tutorial_2.txt. Click Save. It now can be used in new drawings as shown here. In this tutorial, you learned how to change the name of the structure definition, customize and add new attributes, sort attributes, add new visualization types, and reuse your structure definition.